I'm Steve Pack, head of product at O1 Labs. We were the other company that submitted to the RFP and were selected. So for those of you who are new to us, so we incubated the Mina protocol. We've been at the cutting edge of Web3 and zero knowledge for many years, having launched Mina mainnet back in 2021, the first ZK succinct blockchain. We're also the team behind O1JS, which is a TypeScript library and embedded DSL for writing ZK-powered smart contracts. So if you're looking to add ZK to smart contracts or dApps, check it out. And now we're helping to decentralize the OP stack with the MIPS ZK VM. So I wanted to start with the why before we sort of get into some of the detail. Like, why did we answer the bat call when Optimism put up the ZK bat call? Why did we answer? A few reasons. This was very complementary to our existing tech stack. We've had a proof system in production securing Mina for many years. A ZK VM was actually on the Mina roadmap, so it was great to be able to sort of benefit two different ecosystems from the same work. And then, of course, the growth of L2, users are flocking to L2 in Ethereum, low gas fees, fast confirmation times, and developers are flocking to the OP stack. I think really valuing the modularity, and we've benefited from that too in this implementation, which I'll mention. And yeah, we're excited by the Superchain vision. O1's actual mission is to catalyze a new generation of apps powered by ZK technology, and that is this. I'll talk in more detail, but getting us to a point where we can have faster L2 to L1 withdrawals, like that's a super tangible outcome of this work. And similarly, L2 to L2 messaging opens up a whole host of new things, all powered by ZK, which is exciting. I wanted to share this. This is actually from Optimism's own blog post on the pragmatic path to decentralization. When you look at this RFP and you hear a ZKP of Optimism, it's kind of like not always clear where this sits or why. And I thought this post did a really good job of laying out, and I'll just quickly share that Ethereum has achieved a lot of reliability with client diversity. And so Optimism's taking a similar approach to fault proofs and having multiple VMs to run fault proofs. And when you combine the product of the clients and the VMs, you get lots of different signals. And so this sort of is moving to a potential future world, should the governance process vote for something like this, where a smart contract could just look at these signals of the proofs coming in and make a decision based on a majority. Getting away from centralized contracts and upgrade keys, things like that. And so the exciting thing about this is exactly on that road, right? It's another VM, this time a ZK VM, and it's not just producing fault proofs, but validity proofs. And so, this is I would argue, like a higher signal in terms of being able to sort of trust, the absence of any faults in the proofs. And so I think it's really helpful to think about this as, a really important step in the path to decentralizing the OP stack. So that's a little bit about the why. Quickly on the what. So similar to RISC 0, whereas their build have a RISC 5 ZK VM, ours is a MIPS ZK VM. Couple of things about this particular project. We have a optimized low-level catch-hack implementation. There's a lot of calculating and verifying hashes from blocks. So there's, I mentioned the OP stack was really modularized. So this is the sort of proof is in the pudding. Our implementation here was, interfacing with the pre-image oracle. We didn't have to know so much about what the proof, what the fault proof program itself was doing, just implement the VM interface. So a couple of other things I'll call out. Our proof system was optimized for Mina, uses a different curve. We needed something efficiently verifiable on Ethereum, so we introduced KZG commitments. And so, yeah, here's where we are in the process. So a number of components completed, still working to complete the RFP to execute end-to-end. Already lots of opportunities for optimization that we can see. It's a really rich design space, things like in the instruction set itself, GPU parallelization, also changes to Canon. There are things that Canon does, like reading very small bits of memory that could be larger chunks that would be more efficient in ZK land. But I think the most interesting thing, and this is the first call to action for the community, is what's going to be the mechanism for these proofs to be generated? How is it going to be funded? What sort of economic models, incentive models are there in place. And, I think that's a really interesting space for the community to explore as well. But the ask for today was to do a workshop, and so have some, some interactive components. So if you want to get your hands dirty, start with following the issue. Literally, if you search RFP for OP Stack ZKP, you'll find it. Join the conversation. Comment on the issue. Join in Discord. How would you like to see this evolve? And then for actually working on our ZKVM, I'm going to help you get started so that you're ready when it lands to be one of the first to execute a full ZKP of Optimism. So a couple of things. You're going to need an Ethereum full node. It's not enough to point at Infura or something like that. So wherever you run this, you're going to need Ethereum running in the same network. Similarly, you're going to need an Optimism node. Both of these get input to capture all the L1 data and derive the L2 state. But if you can't wait and you really just want to play with something today, we, as I said, do have the low-level implementation of Ketchak. And so far, early numbers we're really happy with. They're as good as any implementation we've seen on the market so far, and we're going to talk a bit more about that as we sort of benchmark more scientifically. So let's take the risk, shall we, and go live for some funsies. So if you want to get started, clone the repo, like I said. Didn't think about the two-handed thing, but let's try. So most of the code is in the Optimism folder. So like I was saying, these are the scripts to help you get your environment set up. You'll then be able to run Canon, which is the current fault-proof VM, and then you can run the same fault-proof using the MIPS ZKVM. Check you get the same output, but also get the zero-knowledge proof. So coming in hot, not quite ready for you yet, but getting close. But for those who can't wait, let me just see if we can get to. Oops, sorry. Oh gosh. That's why. Okay, so if you're going to run the tests, just use the command. I've got that in the slides. Make sure you use the release version. But initial test, just sort of hashing 20 blocks worth of data in Ketchak. This is on a Mac M2 coming out at 3 seconds. So that was, six blocks a second. We'll speak more about this as we start to put real benchmarks in place. But this is one thing I wanted to share an early look at if you want to start playing around. That's it. Thanks. Any questions? Come up, Rami. Yeah. Yes.
Why do you need a local node? Why can't you work with Infura?
The way it was explained to me, we don't get all of the block data that we need from Infura. I don't know whether it was call data or we can ask an engineer in the room. Actually, what's missing from Infura that we get from the full node, Danny?
So we tried with Infura, and first when we were running Canon, it was too many requests that we were doing first, and also we needed a full node.
But do you know which piece of data was missing besides hitting the request limit?
No, I just saw it wasn't working, and I said, okay, let's set up a full node.
Okay, maybe we'll update the README with a more scientific answer when we get what was missing. But yep.
How can ZK stuffs work with the L2 optimization?
Yeah, great question. I know Optimism are sort of foundation are spending a lot of time thinking about that and doing that. It's an emerging space. I guess the idea is that if one chain can be sure about the state of the other chain by verifying a proof, which maybe only takes a few minutes to generate, then that second chain can, take action based on a message without waiting the full 7 days. Now, that'll depend on the risk appetite of the various parties, like, how many different implementations of ZK there are, like how much the ecosystem trusts it. But I guess it's that idea that verifying a proof can give you surety in a similar way that the challenge window does, but much, much quicker.
Well, but the messaging has to be happen instant, so means that every 2 seconds we have to build a proof. Means that can we really build a proof within 2 seconds for the message?
Not today, no. And so I think, on the receiving end, there'll have to be a sort of decision around how optimistic you are, how tolerant you are to chain reorgs, and anything to add on that? Any other questions? It's an emerging space though, and super, super exciting. Plant question. Yeah, got one more here.
Building on the emerging space, how long until this becomes viable and easy to use for a TikTok attention span developer?
Pass. Rami?
I need to decipher that term. I don't even. What's a TikTok?
You have to repeat the question.
What is it?
So it's an emerging space, right? How long until this becomes very easy to use for people with very low attention spans? So I don't have to.
Okay. Yeah. No. It won't. I don't think so. Yeah.
It's still some rough edges, I think.
I mean, you'd have to ignore a lot of the details of the things that you're using with that kind of attention span, I would say. So.